Relative density. Equal volumes of different materials have different masses. For example, if unit volumes of cotton, cork, lead and mercury are weighed separately, their masses are found to be 5 grams, 20 grams, 100 grams and 275 grams respectively. It is because they have different densities. In this example, cotton has the least and mercury the highest density. Density of a substance is obtained by finding the ratio of its mass to its volume. In SI units, it is measured in kilogram per cubic meter, and in CGS system, its unit is gram per cubic centimeter. Here is some cotton kept in a container, occupying almost whole of the container. Now this cotton is compressed, and another lump of cotton is placed in the same container. Can the cotton in the container be compressed still more? Yes. We can add some more of it in the same container, and every time the cotton is compressed, thereby its density increases. This implies that the density of a material increases if its particles are brought closer. Under specific conditions, density of a substance remains the same. Therefore, it is a characteristic property of a substance by which it can be identified. If 1 piece each of iron and wood are kept on the surface of water, iron sinks as its density is more than that of water, whereas wood floats because its density is less than that of water. As a rule, whenever a solid is kept on the surface of a liquid, it sinks if its density is more than that of the liquid and floats if its density is less. Let's compare the densities of different liquids. Pour some glycerine in a tumbler with the help of a glass rod. Next, pour some colored water in the same container very slowly again along the glass rod. Notice 2 distinct layers of the 2 liquids. Glycerine is heavier than water and thus remains settled at the bottom. To your interest, we can slowly add another liquid of a still smaller density, say edible oil, to the container. This also forms a distinct and separate third layer. Let's pour some spirit gently over the liquids in the container, which forms the uppermost layer. As it has the smallest density among all of the 4 liquids in the container, let's pour some sugar syrup gently over the liquids in the container, which forms the lowermost layer. As it has the largest density among all of the 5 liquids in the container. So, the spectrum of different liquid layers is based purely on their densities. If we further drop an iron piece into the tumbler, it sinks to the bottom. But if we drop a wooden piece, it sinks up to certain layers but floats on the water layer. Whereas a cork piece floats on the topmost layer as its density is the lowest one. 100 grams of a liquid completely fill a 200 milliliter bottle. What is the density of the liquid? Since 1 milliliter is equal to 1 cubic centimeter, therefore, density of the liquid comes out to be 0.5 gram per centimeter cube. If a block of copper measures 2 centimeter by 4 centimeter by 5 centimeter and weighs 356 grams, what is its density? Since the density is the mass per unit volume, thereby density of copper comes out to be 8.9 gram per centimeter cube. Peanut oil has a density of 0.92 gram per centimeter cube. If a recipe calls for quarter cup of peanut oil, what mass of peanut oil is required? Take 1 cup equal to 240 ml, since the mass is the product of density and unit volume. Thereby, mass of peanut oil in quarter cup is 55.2 gram. We know that for a floating object immersed in a fluid, partially or completely, the weight of the fluid displaced by the object is equal to its own weight. Hence, the density of the object as well as its volume and the density of the fluid play an important role to decide whether the object will float or sink. To determine the density of a substance, we need to know its mass and volume. Mass of any object can be determined easily by using a balance. But when the object is irregular in shape, it is difficult to measure its volume accurately. In such cases, instead of measuring its density, we determine the density of the substance with respect to the density of the reference liquid, which is known as relative density or the specific gravity of the substance. Since it is the ratio of two similar quantity, thereby it has no unit. Generally, water is used as the reference liquid. Thereby, relative density of a substance is the ratio of the density of the substance to the density of water. Generally, we use the density of water at 4 degrees Celsius as it is 1 gram per cubic centimeter. If the total volume of a floating body is V and V0 outside the fluid, let ρ is the density of the fluid and sigma is the density of the object. For the object to float, weight of the fluid displaced by the submerged part, that is ρg into V minus V0, must be equal to the weight of the body, which is sigma gV. And the submerged volume, V minus V0, comes out to be the product of the volume of the body and the relative density of the body with respect to the fluid. From this expression, it is clear that if the density of the immersed body is more than that of the fluid, the volume of the submerged part becomes more than the total volume of the body and hence the object will sink. But if the density of the immersed object is equal to the density of the fluid, then the volume of the submerged part becomes equal to total volume of the body, that is, the object will float and just completely submerged in the fluid. And if the density of the immersed body is less than that of the fluid, the volume of the submerged part becomes less than the total volume of the body. That is, the object will float and partially submerged in the fluid. Since the ratio of the densities of the body and the fluid is the relative density of the body, thereby the law of flotation can be redefined as: if the relative density of the immersed body is more than 1, it will sink. But if the relative density is equal to 1, then the object will float and just completely submerged in the fluid. Furthermore, if the relative density is exactly 1, then the densities are equal. That is, equal volumes of the two substances have the same mass. On the other hand, if the relative density of the immersed body is less than 1, it will float and remain partially immersed in the liquid. For example, an iceberg with relative density 0.91 floats on water. For the same reason, huge and heavy ice glaciers float in oceans. Relative density can also be used to determine the proportion of a floating body that will be submerged in a fluid. For example, if a body is 2/3 as dense as the fluid, then 2/3 of its volume will be submerged. We know that a piece of iron sinks in water and floats in mercury because its relative density with respect to water is more than 1, but with respect to mercury, it is less than 1. Similarly, when we drop a can of normal Coke in water, it sinks, but the can of Diet Coke floats, because the relative density of normal Coke is more than 1, while that of Diet Coke is less than 1. Similarly, a hot air balloon rises in air because of its relative density with respect to the air outside the balloon. Hydrometer is a device to measure the density of various liquids relative to the water. Most commonly, it is used to measure fat in milk, alcohol in liquors like beer, wines, and water content in urine. We know that human body floats higher in the salt water than in a pool of water. The same analogy is used in hydrometers. Submerged volume at 1.000 reading is exactly the weight of the hydrometer when it is immersed in a liquid and its reading is more than 1, then the relative density of the liquid is greater than 1. Let us take 3 beakers containing olive oil, salt solution and water respectively. Hydrometer is placed in each beaker. Sinking of hydrometer shows the density of the liquid. As in case of olive oil, it sinks most. That is, buoyant force in olive oil is less. Hence, density of olive oil is also less. It sinks least in salt solution. That is, buoyant force in salt solution is more. Hence, density of salt solution is also more. Relative density can also be defined as the ratio of the weight of the solid and the weight of the equal volume of water. Since the relative density of a solid is the ratio of the density of the solid and that of water, for the same volume of water, it becomes the ratio of mass of solid and the mass of water. Since the weight of a substance at a given place is proportional to its mass, therefore, relative density can be defined as the ratio of the weight of the solid and the weight of the equal volume of water. Furthermore, when the solid is completely immersed in water, it displaces equal amount of water. Therefore, relative density can be defined as the ratio of the weight of the solid and the weight of the water displaced by the solid. According to the Archimedes principle, this weight of displaced water is the loss in weight of the solid in water. Thereby, the relative density can also be defined as the ratio of the weight of the solid and the loss in weight of the solid in water. In general, for any liquid, it can be the loss in weight of the solid in the liquid. Some numerical problems. A sample of milk diluted with water has a density of 1048 kg per meter cube. If pure milk has a density of 1080 kg per meter cube, then find the percentage of water by volume in milk. Let capital V be the volume of the diluted sample of milk, and small v is the volume of water in the sample. Then, the volume of pure milk is capital V minus small v. Density of sample of milk is 1048 kg per meter cube. Density of pure milk is 1080 kg per meter cube and density of water is 1000 kg per meter cube. Since mass of the sample of milk is equal to mass of pure milk plus mass of water, this gives the ratio of volume of water in milk and volume of the given sample of milk as 0.4. Therefore, 40% of water is mixed in pure milk. In our next problem, a piece of pure gold of density 9.3 gram per centimeter cube is suspected to be hollow inside. It weighs 38.250 gram in air and 35.865 gram in water. How will you check it? If there is any hollow portion, how will you measure the volume of the hollow portion in the gold? If the volume of the gold piece is less than the volume of displaced water, it will indicate that it has hollow portion. Here, density of the pure gold is 9.3 gram per centimeter cube and mass of the gold piece is 38.250 gram. Therefore, volume of the gold piece is 4.113 centimeter cube. Since mass of the gold piece in water is 35.865 gram, therefore, apparent loss in mass of the gold in water is 2.385 gram. The apparent loss in weight of the gold piece is equal to the weight of the displaced water. Hence, the volume of displaced water is equal to the ratio of its loss in mass and density of water, which is equal to 2.385 centimeter cube. Since the volume of gold is more than that of displaced water, it has no hollow portion, but it contains some impurities.